Hello everyone, welcome to AI Anytime channel. In this video, we are going to deploy a large language model Llama 2 on AWS SageMaker. Yes, so we are going to take the model which is available on Hugging Face and we'll use AWS SageMaker to deploy this. Okay. Once it is deployed, we'll also create a Lambda function and probably your API gateway or directly a function call from that Lambda function in one of our application. So it's going to be a couple of videos. So it's going to be a playlist, and so it will be a series of videos, and we'll start with this deployment and then we'll build some cool application, okay, where we will leverage this deployed model. Okay, and I'm going to use something called DLC. You can see it on screen. It's called deep learning container. It's in partnership with AWS and Hugging Face, and where they have this DLC setup for you. So you don't have to put a lot of efforts when you are deploying this transformers based model, probably, or few of the other models which are available on Hugging Face. You can use deep learning containers DLC. It's available in the SageMaker Hugging Face class. I will show you when I'm writing the code, and you can just use the DLC frame, basically this deep learning containers, to utilize the pre-installed deep learning frameworks and libraries such as transformers and datasets. Few lines of code, select an EC2 machine, deploy it, and use it wherever you want to use it. That's what we are going to do. So remember, we are going to use DLC. This is not the only way of deploying a Hugging Face model on AWS. You can deploy it manually, download all the model weights files, put it in an S3 bucket, configure it manually, write model function, and deploy it using Hugging Face SageMaker class. It SageMaker Hugging Face class, but you can do that manually as well. You can configure it, you can do it through DLC. There are many ways of deploying these models, to be honest, but I find this is the easiest one to deploy. Let's see what we're gonna do here, guys. So you can see currently I'm on my AWS console. This is not an AWS video, by the way, but I'll try to cover a few things. So you can see I'm on the console and this says recently visited. So I will go inside SageMaker. So let's go into Amazon SageMaker, which is one of the AWS flagship offering, when it comes to AI and machine learning, right? And you can see that I'm currently on this SageMaker part, and you can see some domains where you can set your domains as well, for example. And I'm more interested in notebook. I'll go to notebook instances. They have a lot of other things, guys. Here they have studio lab, they have jumpstart, where they have foundational models. Now you have all this LFM, large foundational models. Okay, all of these foundational models which has which SageMaker has, for example, Falcon 40B, MPTs, etc. And then they have studio and studio lab, where you can also use their one of the recent offering called AWS Bedrock services. They have Titan models. They want to compete with GCP and Microsoft Azure because they think that they are left behind, when it comes to generative AI. And I leave up to you guys. AWS is powerful, but they think that they have left behind, and they're now trying to catch up, with all of this recent development in the AWS ecosystem, and I appreciate that. So you can see we have something called notebook, and they have notebook instances. They have Inference. We'll go to Inference later once we deploy it using DLC. Let me go inside notebook instances. So I'm going to go inside this notebook instances, and then I will create a notebook instance here. Now if you are deploying a large language model through DLC, deep learning container, you can just take the smallest of the machine, just to create a notebook, because for deployment anyway, we are going to pass a machine that supports that model, at least for deployment standpoint. So now here I'm just going to call it Llama to deploy, something like this. Okay, Llama to deployment or something, and it's fine. You can see I have my IAM role given. If you are coming and using it for the first time on SageMaker, you have to assign all the like if you have roles, if you want to assign roles, you assign roles. If you and you have to attach inline policies, for example S3 full access, SageMaker full access, or you can also choose what you really want to attach in the policies depending on how you want to configure it. So make sure that you have an IAM role and the policies are attached to that role. Okay, anyway, now let's click on notebook instance. When I click on notebook instance, you can see it says success, your notebook instance is being created. It will take little time, so let it load. So right, so as I said, we are going to deploy Llama 2, which is which is like a new version of the Llama, which is by Meta AI, a commercially available open source large language model, okay, which has been trained on around 2 trillion tokens, and supports context length windows of up to 4K tokens, and it's a breakthrough. Llama was a breakthrough, and Llama 2 has really been helping the researchers, the academia, the enterprises to build solutions on open source large language model. And so Meta has basically fine-tuned Llama 2 on reinforcement learning from human feedback on over 1 million human annotations. So I'm not going to cover anything on Llama 2. There are multiple videos already available. So it will take little time. So what I'm going to do here, I'm going to go inside my gist on GitHub. I'll take few things from there. I'll just go inside your gist. I'm not going to write a lot of codes. And let me also go inside Hugging Face. So let me just go inside Hugging Face here, guys. Okay. And I'll just go on this models, etc. And you can see I'm already here. I'm going to go inside settings. We need access tokens here. So I'm going to click on access tokens. And we're going to use this for probably because these are gated models. And for gated models, you need a API key to authenticate with Hugging Face Hub. And that's why we need an access tokens. I'm going to use couple of gist. I'm not going to write a code because these are very redundant. You can get it in the SageMaker documentation as well. Okay, fine. So then let's do that. Okay, and the first thing that we have to do, we need SageMaker on this version at least greater than or this 2.175.0. Okay, now let's come back here on the notebook. It's still taking little time. It will take few seconds. It's okay. So the DLC that we are going to use is, guys, powered by TZI again, and I hope you are aware of TZI, text generation inference. It is a scalable, optimized solution for deploying a large language model. If you want to deploy, go ahead and consider TZI for your workplace. Okay, and for this we need a virtual machine, an EC2, excuse me. We need a machine of let me go to SageMaker pricing. By the way, I'm gonna come on SageMaker pricing, Amazon SageMaker pricing. I'll show you which machine we need, at least the minimum specs to deploy this 7B model. We're gonna deploy our Llama 2 7B here, and if you see, let me come down and excuse me, we need G5. We need G5. Okay. Here we go, guys. We need at least G5 2x large. Okay, so we need at least ML G5 2x large, to deploy a 7B model on SageMaker, and you can, of course, it is available on my here as well. I'll just show you. So let me just show the hardware requirement. You can see G5 2x large, which has one number of GPU, and 7B you can deploy it. If you want to deploy 13B, you consider G5 12x large, which has 4 GPUs, and then you have 70B. You also have, there are two ways you can deploy. If you want to use bits and bytes, just to like deploy on a little affordable machine, you can go at 48x large. But if you just want to go raw, you can take P4D 24x large, which will be really costly for you. So anyway, let me just do a refresh. I really don't know why they are not able to start this, but it's taking a little time. Okay, now I'm going to start my Jupyter Lab here. Once you click on Open Jupyter Lab, it will open a Jupyter Lab inside it, and it takes. Let's take a moment. Okay. I'll go back. We're gonna use this sales role.py, and I can give this gist to you, and anyway the code will be available on the GitHub repository, so you can just take it from there and use it for your deployment. I do have couple of videos on deployment itself, that how you can you deploy a large language model through DLC, deep learning containers. So I have deployed models like Llama and couple of other models. Okay, you can find that in the AI deploy AI model series, okay, on this channel. Okay, anyway, let it open. So you're going to use SageMaker Python SDK to deploy Llama 2 to SageMaker, and you need an AWS account to basically use this, guys. Okay, so let's do that. Okay, so this is a requirement. Let me see if it's still not able to load it. It's loading it. Okay, so let me pause the video here, guys. I'll resume once it gets it starts. The machine is really on. So I'll just pause the video here. Okay, so you can see that now I'm inside this Jupyter lab. So you can also use Jupyter notebook if you want to use to deploy it. So I'm inside this Jupyter lab. It's called Llama 2 deployment IP1B. And I'm gonna do let me just go here on the boilerplate, copy this again, and first I'm gonna upgrade that, and let's do that. So it says pip install SageMaker something, and it will do it. I'm also gonna use this that will print your ARN role, etc. So let's come here, and what we are doing is it's use Boto3, the client for Python, and it has im.get role, looks at your role and all, and this is what it does. Okay, now let's do this SageMaker Boto3, and it will print your role ARN and session region. Okay, now after that what we need is when you have to do a DS, so we have to use this DLC.py that uses get underscore hugging face underscore LLM underscore image URI, and you're gonna use this with the right version, and that will retrieve the large language model image from that DLC, the deep learning containers that we have. Okay, and we'll come here, you can see it has printed out. Okay, and now let's run this, and it says LLM image URI, something, and you can see this PyTorch TGI inference. As I said, text generation inference, so now we're using PyTorch TGI inference here, and the next that we need is this. Okay, now here is what we have to make few changes, so let me just do that, and I'll show you what are the changes that I am making. So let me just copy, come here and make it paste, and let me just do this here. Okay, now what we are doing here, guys, okay, you can see we have import JSON and SageMaker.hugging face import hugging face models. We are using hugging face model class, and we're going to use instance type here, and I'm going to use G5, as I said, ml G5 dot and 2x large. This is the instance, the EC2 instance that we have, ml.g5.2x large. It has 1 GPU, so number of GPU you have to give 1. Okay, and then it has some health check timeout that looks for the timeout for that container, the health check timeout, and then we have health check some configuration for the model and endpoint configuration parameters. So you can see it uses Llama 270B chat HF, and of course we are not using 70B, so I'm going to replace this with 7B. So 7B chat HF JSON.dumps, number of GPU is 1. Then we have maximum input length, of input text, which is 2048. Then we have maximum length of generation, including input text, so both input and your response. And you can see it shoots up to 4096, and you can also have limits of parallel, processing. When we are doing this, generating the responses, which goes to 8192. Okay, now it says hugging face hub icon, and in that case we have to use the hugging face hub icon. So now let's come here and let's use one of the let me just click on this, copied, and I'll just replace this with this. So let's replace this, and you can see I have replaced this with this. Now let's put this inside json.dumps as well. So I'm going to just put that in json.dumps. So let's do that. And here also it says check if token is set, and I'll just remove this bits and bytes because this is okay to keep to 70B if you want to go ahead with 48x large machine in that case. And here you can see it says check if token is set. So let's also put our tokens here, it's for assertion. So you can see it says assert config. So let's just put that, and now it looks okay to me, and it says not equals, by the way. So it says check if token is set. So assert config Hugging Face hub token not equal this, please set your Hugging Face hub token. So probably we'll get an error to basically set that. Now let's run this, and you can see it's okay. And now we'll go back to our GitHub gist. So let me just go at GitHub gist, and here we have, excuse me, I just not this, we still need that deployment class, the module, not class, the module on deployment module from that class, the Hugging Face model that you see. Now we have a Hugging Face model with the image URI in the above step, where we have a variable called LLM model that uses that class and has assigned some role, which is my Gen AI role, and then image URI. So the image URI is nothing but the LLM image, that we have here. You can see LLM image, and then we give the env as your config. So this is your config, the model name, the right set of GPUs, the input, and all the parameters that you have to pass it over there. Now it can take time to deploy. And let's deploy it and see if we are able to deploy this. So you can see it has started, and of course it will take time, or it will probably throw you an error. You might get an error to increase your quota. Okay, and in that case you have to reach out to AWS support. You have to create a case, basically a ticket on the support center or the console, and then you have to create a say, and you have to tell them that, okay, what use case that you are currently working on. You can see my deployment has been started. You can see this here, the progress bar or the loaders kind of a thing. Now if you are facing any problems, reach out to them. You also have to interact, and you have to give it your use case, because they are giving it to people who they think that, okay, you are working on a right set of use cases for Llama 2 deployment or any compute heavy instances if you are using. So you have to give your use case, you have to interact with them, and you have to follow up a couple of times to get the quota increased. And of course if you are part of an enterprise, you would probably have this already, but I'm talking about individuals or the people who are in the academia or universities, etc. right? So for your hobby projects, you need that quota to be increased. Okay, and it will take time, so I will pause this video here, guys, and I will come back once it is completed. Okay, fantastic. You can see that the model has been deployed, guys, here. And once you see successful, it means that you have deployed the model. Let's see what we can do here. So basically this is a conversational chat model, guys. Okay, so it can have chat through some prompt structure, and the prompt structure for this starts like this. When we see it has instructions, and then it has the closing. So basically everything is caps. So system, and then you write your system prompt here. So system prompt, and then you and of course I'm just showing you, it's underscore system prompt, and then you end again with sys and something like this. Okay, excuse me. This is how it looks like, and then you have user message, etc. into it. So we have to convert basically using a function. So we have to build the prompt. So I'm going to copy this, and this is we have taken from Phil Smith blog. So we'll just take it from here and we'll just paste it. Okay, now what we are doing here, it says build Llama 2 prompt, and you can see the start prompt and how the end prompt. So it will start, then it will end, and there are a lot of things that you can use it here. You can use negative prompting, different type of flags if you are getting. So most of the people were saying that when they use Llama 2, excuse me, I'm getting this server dismissed. Let me just dismiss it. Most of the people say that they face this problem of generating duplicated tokens or words, okay, repeating words. Okay, and then you can also take care of that. You have to basically write a couple of flags there that you can use it. Now let me just run it, and you see I've written this build llama to prompt function that will probably take the way you want to interact with that large language model llama 2 in this case. Okay, so we have built this prompt, and what we are returning is start prompt plus join the conversation plus end prompt. And if you see the messages, system content, also let me just write something. So for example, if I give an instruction, okay, so instruction, and the instruction is, for example, give me some ideas, what to do when I am free, something like that. Okay, what to do when I am free. Let me just put a question mark. This is one of your instruction. Then what you can do messages, because we have defined messages on top. If you can see messages dot append. So let me just do messages dot append. You can see it takes, excuse me, it takes, so it's let me just close this, messages dot append, and it can key value pair. So let me just keep the key value pair messages dot append. So it becomes role. So one is role, you can see it over here in the above cell, and after role, user, and then you have context. So let me just give content. So let me just give content, and content is your instruction. So content become your instruction. So let me just write this instruction, and then you have prompt. So let me just do prompt, and you can use this function that we have defined on top, build underscore llama underscore 2 prompt. Okay, build llama 2 prompt. So let's use that, and we're gonna pass message. So let's pass the messages, and then just gonna use in a chat so let's have a chat variable. We're gonna use llm.predict. You're gonna use this predict. So the endpoint would have been created. I'll show you the endpoint in the SageMaker dashboard. So llm.predict, and we're gonna pass, it's a key value pair. So we're gonna pass your inputs, and inputs are nothing but your prompt that you have on top. So let's close this now, and just gonna print the chat. And so let's just print chat. That's what I'm gonna print here, and the format is generated underscore text, and you can also get the length of that prompt. So len, and it's a function, so pass prompt, excuse me, and yeah, that's it. So now let's close this with this, so print, and now let's run it and see if you are able to get our response. Okay, so you can see it's generated. It says, oh wow, I am so glad you asked. Now you have to again run inference with different parameters, because to impact the generation, because it might not be what you are looking for. So the parameters can play a huge role. We have temperature, we have penalties, we have sampling, we have then we have temperature, etc. as we discussed. So let's create a payload. As in most of your AWS SageMaker GitHub repositories or blog, you would have seen it that we create a dictionary here, and inside this we write all of the payloads. So let's now write the payload here. So the first thing is your inputs. So let's just define that inputs, and your inputs are nothing but becomes a prompt. So let's just write that prompt. So I'm okay with it. Now you have prompt. Now what else we have? So now here goes all of our parameters. So in that parameters, first we define the parameters here. So let's define a parameters, and in this parameters again it's a dictionary. So let's me put it over here. Okay, in this parameters, and the first thing is do sample. So you can find all of these parameters on TGI Swagger specification. I can give that link in description. It's available there. It's also available on the GitHub repository, by the way. It's a true or false. So let's just make true for do sample, and then we can use top P. So pretty much if you would have work with many LLMs, you would know all this inference parameter, okay, not hyperparameter. Okay, so top P as 0.6, and then temperature for randomness, creativity. So let's have temperature, and I'm gonna write, let's have a higher temperature to so model can become a little creative on that. And if you want your LLM to to be more deterministic, then you should keep this model to 0, 0.1, 0.2 or something like that. Okay, now we have temperature. I hope I am spelling it correctly. Temperature, then we have top K, and it goes, let's keep a value 50, and then we have max new tokens. So, and this plays some huge role here, guys, you know, the max new tokens. So I'm gonna say, okay, max new tokens should be, let's give 512 for now. Okay, the max new tokens, and then we have penalty, so let's call it repetition penalty. Okay, let's set this repetition penalty on the tokens that you are generating. So repetition, TITION, I hope it's right, repetition penalty, and this is let's set something like 1.03, the standard. You'll find that, guys. So stop. And so how do we stop this? So we stop, we already have seen above that how do we stop. So we stop with okay, so stop, and I think we are okay with this now. So let me see. So payload, and then we have inputs, which is your prompt. So inputs prompt parameters to which I guess fine. Let me just give a, let's see. Okay, no, your parameters do sample. Let me just give a space true, and let me just give a space here to the IntelliSense that is working. Max new tokens, and then we have top K. Everything looks nice here. Now let's run this. I'm just gonna run this here, payload, and now again we're gonna use. So now let's send this payload to the endpoint that we have, you know, created, or the model has been deployed. I'll show you how an endpoint looks like. And response equals llm.predict, the predict function, you know, from that SageMaker here, llm.predict payload. Let's run this. You can see it says response llm.predict payload, and now I'm gonna just print the response. So let's print it. So print response, and of course, at the same way that we did, let's have generated underscore text, and then I'm gonna also pass length. So I did a mistake. Generated text. This looks nice, and then we have length of that prompt. So length of that prompt, colon, end, and the function ends. Let's print it. Fantastic. Okay, and you can see it. It says, "Oh wow, I'm so glad." So if you see this here, it says, "Oh wow, I'm so glad you asked." Now here, if you see, it says, "Oh wow, I'm so glad you asked." There are so many fun things to do on vacation, depending on your interest and the location you are in. So if you are looking for something adventurous, have you considered trying water sports like snorkeling and kayaking? It's a great way to explore the underwater world, and, you know, fantastic, right? So we got a good response, you know, guys, from this deployment. Now let me go back to my SageMaker here. So I'm going to open SageMaker again here. So let's open that, notebook instances. So I'm opening my SageMaker. I'm just going to open it. It probably will take few moments. And we have deployed a large language model. We have deployed Llama 2 successfully on AWS. And now we are going to use that deployed model on few of our applications. I'm going to work on with embeddings, and we'll see how we can create some cool apps with this. Okay, now if you come here on this, you can see a notebook instance, Llama 2 deployment, which says in service, and I have taken an MLT3 medium, but when we deployed on a G5 2x large. Okay, and now if you come here on the inference, and you can see the endpoints. Now click on endpoints. You will see endpoints, couple of endpoints failed, and the endpoint that has succeeded. Okay, so you can see this endpoint has succeeded, which is the couple of endpoints were failed because due to reason of my Hugging Face tokens. Okay, now if you see here, you can see this has been succeeded. So let me just click on this. You can see PyTorch TGI. Okay, PyTorch text generation inference. It's in service, real time, model container logs. You can find all of your model container logs. You have your CPU utilization, memory utilization, disk utilization, etc. You can completely, track it out here with model latency and all. Now, so this is fantastic, right? We have deployed a model here, guys. Okay, Llama 2 model. Okay, and the next thing here is that we're gonna create a lambda function of this, and we'll also use a function from there. We'll straight up increase the time of that timeout from the lambda function, and we'll then use this in an application. Okay, but this is fine, right? You have deployed a model without writing a lot of codes manually, using downloading the model weights, creating this inference.py, putting it in a S3, and then zipping it all together and all, right? So it's like a little tedious process. But now here you have with DLC. This is what I wanted to do, guys. In this one, now we'll create a lambda function and we'll use it, and we'll use it in few of our applications as well. So that's all for for this video, guys. I hope you like the content. You got some basic understanding how you can use DLC, deep learning containers, to deploy a large language model easily. And in the coming videos, gonna utilize this model in few of our applications. And please like the video if you like the content. If you got some knowledge, please like it, share the video with your friends and to your peers, share the channel as well. And if you haven't subscribed the channel yet, please do subscribe the channel. Now that's all. Thank you so much for watching. See you in the next one, guys.